field, this is notation for surfaces, whatever that is, over the surface, and the vector field. Since you not have to calculate the numbers, so whatever vector field really didn't matter, right? So you just have to do a dummy one. So what matters is the surface that you really want to know the size of. So this is a paraboloid over a rectangle. So it's already given in the case of a function. By the way, if you have an inequality, less, more or less the same. In terms of surface integral, it's unchanged. So don't be panic if you see no equality sign. Sometimes it could. Okay. And, all right, because this is a surface given by a function, and then we have a specific formula reduced in terms of if I remember right, it's minus pgx minus qgy, and typically g is here for the surface, defining the g is the function defining the surface, plus r. So this is a formula regardless of surface. And the certainly you just plug in and respect. Let's keep the name for a moment. And the p is y. P, q, r is minus p, which is y, times g of x, which is 2x, minus q, which again y, nothing wrong with that, and gy, which is 2y, and plus r, which is x cubed. And the good news is there's no z anymore already from the vector space. If you had a z in one of these components, you have to make substitution at the same time. So make the example more meaningful. I change the p temporarily as z times y, for example, okay? Instead of just y, which means you have to put z to be equal to here. I took the example from the book is they didn't do it. The better example would have been this. The reason they didn't do it, they want to evaluate the interval at the end. So they don't. But if you had a z here, you have to make substitution because there's no z variable in the double interval. X, y are the only variables to be integrated with. All right. So if this is a z change, that will be this. If not, it's just without this. Okay? And yeah. So the next thing you do, you have to put the limits down without integrating. So depending on the order, let's say we start with y without in default. So let me drop this again. So we're doing the original problem, 2xy. Yeah, minus 2xy. No, that's wrong. It's minus 2xy minus 2y squared plus x cubed, and then dy, which is from 0 to 3. You have to hook up the correct order, and then followed by integral the x variable from 0 to 2. That's the answer. I know it's doable, but you stop here. So you don't have to really find that. Those of you who need to answer this, you just finish up that, which is very doable. Even with z substituted, it's still just a multiplication of variables. But certainly, we're not interested in the value of it. Instead, the way of carrying out in terms of a known interval, a double surface. Okay? So that's number 4. You're going to do one of those like that. Make sure that the chances you're going to hit into z component as well, which means you have to make substitution at the same time. Or you can write a z here, but do one more step, substituting later. It's okay, as long as you eventually did it of substitution. Okay? number 8 is about